Hi everyone, welcome back to this channel. In my previous videos, we discussed historical simulation, bootstrapped historical simulation, EWMA, and Garch models for value at risk. Today, we are going to talk about a very powerful and widely used risk model called filtered historical simulation. This method is extremely important because it combines the best parts of historical simulation and volatility models, and it is commonly used by banks and risk teams. Let's first understand why we need a filtered historical simulation. In plain historical simulation, we assume that all past returns are equally relevant today, but in real markets, that is not true. Markets go through volatility regimes. Sometimes markets are calm, sometimes markets are very volatile. Historical simulation ignores this completely. On the other hand, models like EWMA or CARSH captures volatility changes, but they assume returns follow a normal distribution, which is also unrealistic. So filtered historical simulation solves both problems together. The core idea of filtered historical simulation is very simple. Separate volatility from returns. We do this in several steps. First, we model time varying volatility using EWMA or GARCH. Then we remove volatility from returns to get standardized shocks. Finally, we reapply today's volatility to historical shocks. So history gives us the shape of shocks. Models gives us today's risk level. So let me explain the steps clearly. Step number one will be that we are going to compute returns. We calculate daily portfolio returns, usually simple returns because they map directly to P&L. Step number two will be we estimate conditional volatility using EWMA or GARCH. This gives us volatility for each day. Step number three will be filter returns. So we divide returns by volatility to get standardized shocks. You can see the formula here, this one here. Okay. Then in step number four, bootstrap shocks. So now we randomly resample these standardized shocks instead of returns. What will this help us? It is going to preserve fat tails, skewness, and extreme events. And in step number five, we are again going to rescale using today's volatility. So to similar tomorrow's return, we multiply bootstrap shock by the latest volatility. Okay. So and in step number six, we are again going to convert to PNL and calculate VAR and expected shortfall. So these are the six steps, and I'm going to show you by uh, going through these steps in Excel. So I'm going to quickly show you the Excel implementation. So let's start with the data setup. In Excel, this is my portfolio where column A contains the date. Column B contains the closing prices of dollar INR for these particular dates, and column C contains dollar JPY prices. And the portfolio consists of 60% dollar INR, okay, and 40% of dollar JPY. Our total portfolio value is 1 million US dollar. Fine. So in column D, what we are going to do, we are going to calculate dollar INR simple returns. These can be calculated by this formula. So today's uh, closing date minus previous day's closing date divided by previous day's closing. Great. Simple. We can just drag it. Okay. Then similarly in column E, we calculate dollar JPY simple returns. It's again similar to the what we have done previously in dollar INR. we minus today's closing rate of dollar JPY with the previous days of closing rate, and then divide this amount by previous day's closing rate. So we just simply calculate this. So we get our portfolio return. So it is we take dollar INR, this amount, then we multiply by this amount into 60% weightage. Then we again add second term of dollar JPY, this multiply by it by 40%. So we mm, get a weighted average return, and we can drag it for all the for all these dates. See, so these are the just quickly just showing you. If you want to just go step by step that how should I calculate them, then you can just see my previous video. Then we are going for to calculate EWMA parameter. So first we are going to use lambda, which is 0.94. I'm storing it in a separate cell so that it's easy to change later. So we are now going to calculate USD INR EWMA variance. The formula is here. You can see. So we are going to use this formula. So we what we have done that we just taken the variance after 20 days, because we are assuming that after 20 days we have a substantial returns. So we have it's a rolling variance. So it has been calculated for these many days. So you can just check that where I have put on these formulas. Similarly, I have done for dollar JPY as well. Okay, you can see. Now these are the initial parameters for both. For next day, because it is recursive, so for next day, we are going to use this formula. Lambda times square of standard deviation of previous day plus 1 minus lambda times returns of previous day. If you see here, lambda is constant. So cell number P2 0.9 uh, 0.94 times G22. So it is like G22 that we taken the previous day's variance plus 1 minus lambda into returns square. So previous day's returns square. We have done a square root. It is already a variance, so I directly took variance here. Okay, so it's standard deviation square. So I directly took variance. So we can just use this formula, and we can drag on this formula for all up to last row. Similarly, we can calculate dollar JPY, EWMA standard deviations for all upcoming days. And in column I, we are going to calculate EWMA covariance. So first, similar to our previous approaches, we are going to take the covariance of these two currencies, how these currencies have moved for 20 days. We are going to just initiating a parameter here. Then we are going to calculate EWMA covariance using this formula. It's just it's similar to previous EWMA variance for individual currencies. Only difference is that here we took the returns of previous day and we have taken its square. Here we are going to multiply the returns of both the currencies. So this is simply like shows here. So lambda multiply by covariance previous day covariance plus 1 minus lambda, okay, multiply by return of dollar INR, previous day return of dollar INR, and previous day return of dollar JPY. Okay, and we will drag this for till the last row. If you see, we can going to have similar values. So we are going to calculate the portfolio variance. So portfolio variance can be calculated using this formula. It is square of weights multiplied by variance of dollar INR plus square of weights of dollar JPY into standard deviation or square of standard deviation or variance of JPY plus uh, 2 times W weighted average of dollar INR into weighted average of dollar JPY into covariance. So we are going to calculate portfolio variance. Then we are going to ignore the step number 6 and 7 because these are for EWMA. So now we are going to calculate shocks. So what we are going to do? So we are going to divide portfolio variance. So we are going to divide portfolio variance by it's a basically it's a return. Okay, so I was a little bit confused that I've already taken the square root, so it's portfolio standard deviation. Portfolio standard deviation. Okay, so we are taking the portfolio standard deviation. So we divided the previous base portfolio return by standard deviation, portfolio standard deviation. So we got individual shock parameters for all these dates. Now, what we are going to do, just a moment. So we are going to just randomly sample these standard shocks. Okay. So what I'm going to do, I found out all these shocks. Okay. And then I'm randomly just allocate these shocks. So I'm going to use a formula called index. Okay. I'm going to apply for all these shocks that I've found out. And then I'm going to randomly allocate. So if you see these values are changing every time, right? So randomly, these are being randomly allocated. And now we are going to find out the PNL. So again, if you see in my previous videos from here, so we calculated the standardized returns. Then we bootstrapped standard shocks. Now we are going to again rescale using latest volatility. So we will find out the returns, fresh returns using this formula. So we are going to this shocks we will get randomly, and we are going to use EWMA, the standard deviation. So what we are going to do here is we took the portfolio value, then we took this shock which got randomly. Okay, and we are going to just take portfolio uh, variance. So how we get the portfolio variance here? G263. So we are going to take the latest. You need to remember that we are going to take the latest, so current. So this is the most recent one. Okay, so we are going to take the latest volatility. So through this we will find out the bootstrap PNL. Then what I'm going to do, I'm going to find out the percentile. So if I show you this step again, so we are going to find out the percentile for we are going to find out 95 percentile VAR for these bootstrap. Okay, so if I find check it, so if you see it closely, these values are changing frequently, so we can't trust these, right? So what I'm going to do, I'm going to run it for 1000 iterations. Okay, sequence. to fill this data table. Data tab, what if analysis, data table, randomly. So it is going to fill these values. So this variance that we are calculated, it is changing rapidly. So what we are going to do that we are going to take an average of all these 1,000 scenarios. So I have what I've done is that I have selected all these 1,000 scenarios, and these are 1,000 different VARs, and I have taken the average of all these VARs. So we it will be approximately around 5,360. So if I press F9, so let's check. So if you see, it is still in a particular range of around $50. So still it is trustable. So okay, it's changing little bit, but yeah, still fine. It's near about 5,380 if I take any kind of midpoint. Okay, so this is how we calculate VAR here. I'm going to just highlight it. Now, and how we are going to calculate the expected shortfall. So what we are going to do, we are going to take the average of all those values which are lower than this VAR. So this is the formula that we are going to use, that average if in this all 1,000 iterations, if there are values which are less than this $5,403, we are going to take the average of those values. So we are going to find out the expected shortfall through this. It's also keep changing. Cool. So see if I'm pressing F9. So if you see, we are also having expected shortfall. It's also changing, but they are both coming into the range. So that's how we calculate the expected shortfall. We calculated for a 95% tile. Okay. So now let's talk about why filtered historical simulation is powerful. So we are going to talk about the advantages first. First one is it is volatility adjusted. Unlike historical simulation, FHS reacts to changes in market volatility. Second advantage is no normality assumption. So unlike delta normal or Monte Carlo VAR, FSS uses real historical shocks. Third advantage is better tail risk. So FHS captures fat tails much better, which improves expected shortfall estimation. Then the fourth advantage is forward looking. So by using current volatility, FHS gives a more realistic picture of tomorrow's risk. This is why many banks prefer FHS over plain historical simulation. But there are few limitations as well because no model is perfect. So if we look over the limitations, the limitation number one will be it is still backward looking because shocks come from history. It's another limitation will be it depends heavily on the volatility model which is being used. If we have used bad EWMA or bad guards, so it will give us the bad FHS results. Third limitation is correlation can still break down during crisis. Okay, so that's why FHS is usually combined with stress testing and scenario analysis. We are going to see stress testing and scenario analysis for the same portfolio that we have done right now, and I will show you that in the upcoming videos as well. So we're going to see when and where FHS is being used. So it is being used by market risk desk for calculating FX and rates portfolio. It is also being used by credit department of various banks. There are few regulatory requirements for calculating VAR and expected shortfall from various central banks around the world. It is also being used for calculating and making internal risk engines. It is being used for stress testing. Normally, it is used when there is volatility clustering happening. So you can see that during COVID times, markets were going down. So there was this brief period of, and there was this trend as well. Also, when the returns are not normal, third is like it is when risk regimes change over time. So if you take the example of dollar INR, after December in over November 2024, the regime change. Why? The new RBI governor joined, and before that, RBI used to keep dollar INR in a particular range. At the time, volatility was very low, and after new governor joined, he made dollar INR control free, and now it become very volatile over time. And also on scenarios where historical tales matter more. So these are the few places that we normally use FHS. So at last, if you're asked about FHS in an interview, you can simply say filtered historical simulation combines empirical historical shocks with conditional volatility models to produce forward-looking tail-aware risk estimates. In short, combined GARCH or EWMA with bootstrap historical simulation. Simple as that. To summarize, historical simulation ignores volatility. Parametrical models assume normality. So filtered historical simulation combines the strengths of both. Okay. So in the next videos, we will look at backtesting FHS, comparing FHS with GARCH and Monte Carlo. Then we are also going to do stress testing and scenario analysis. If you found this helpful, then great, and give me feedback if you can, because I'm also learning. Okay, so thank you for watching.